These are our notes on spheres and hemispheres. You can see the sphere here versus a hemisphere is a half of a sphere, but it includes the base. So, our formula for the surface area of a sphere, as you can see here, is 4 pi radius squared. For the volume of a sphere, we have 4 pi r cubed divided by 3. For a hemisphere, our surface area is 3 pi r squared if it looks like this and it includes the base. But our surface area is 2 pi r squared if we do not want to include the base. So let's say this was a top of an ice cream cone and we just wanted that top portion. It'd be 2 pi r squared. The volume of the hemisphere is 2 pi r cubed divided by 3. So for this first one here, for this sphere, if we were to find the surface area, we would take, right here is surface area, so we would take 4 pi, and our radius in this case is 5 squared. So our surface area for this sphere would be 100. We leave pi in our answer, and since it's in inches, we would have inches squared because it's surface area. And then for our volume, we'll do that over here. Volume equals 4 pi. Again, our radius is 5 cubed. And then we're going to divide all that by 3. So we would end up with 500 divided by 3 pi. Remember, our units are cubic, so our volume for this would be 166.7 pi inches cubed. So that's our volume of this sphere. All right, moving over to this hemisphere, our surface area would be 3, following this one here, pi. Our radius is 3 as well, and we're going to square that. So 3 pi 3 squared. So our surface area for this would be 27 pi, and that's going to be inches squared. 27 pi inches squared. And down here we'll do the volume. Volume would equal 2 pi, we're following this formula right here. Our radius is 3, and we're going to cube that and then divide it all by 3. So we would end up with volume equals 54 pi inches cubed divided by 3. So our volume is going to end up being 18 pi. And remember, our units, we have cubic units, so 18 pi inches cubed. For this next example, we have a combination of a hemisphere and a cone, and we want to find volume for that. So here is the formula that we would use for each of those. So we'd have 2/3 pi, our radius here is 5, and we're going to cube that, plus 1/3 pi for our cone. Our radius again is 5 squared, and our height for this one, you can see right here, going from the vertex to the center, is 12. So for this portion, we would get 83.3 pi, plus, for this part, we're going to end up with 100 pi. And then to find our volume, our total volume, we just want to add these two together since both are in units of pi. In pi, we can just add them together and we don't even have to plug pi in. So our overall answer would end up being 183.3, repeating pi, and we don't have any units in this one, so we're just going to label for this units cubed because we know we're finding volume. So this is what you should find for your overall volume for the hemisphere and the cone combination. In this next example, we have a combination of a cone and a cylinder. So what I did here was wrote the formulas for each. Here's the surface area of a cone, and this is what we're already familiar with. And our cylinder, here's our surface area as well, formula. But for this one, because we're trying to find the surface area, which includes the bases, we only really need this base down here. So in our formula, I kept the base right here, but these two, which would normally be these two bases here, which we should not be counting in, I took those out. So I rewrote the formula to be, this would be surface area is going to be equal to pi r slant plus 2 pi r height plus pi r squared. So if we plug in these values now, looking at the formula, the first thing I see is I've got my radius, I've got my height, but I do need to find the slant. So I can see here with my height and right here with my radius, I can figure out the slant right there. I just have to use Pythagorean theorem. So we'd have 6 squared plus 4 squared equals c squared, because I'm looking for this side over here. So we'd get 36 plus 16 equals c squared. This would be the square root of 52. So c would equal 7.2. So this side right here would be 7.2 for my slant. So to plug this in now, we have pi times our radius is 4 times our slant, which is 7.2. And then we're going to add that to 2 pi. Our radius again is 4 times our height. Right here we can see for our cylinder is 10 plus pi. And for our radius again, we have 4 squared. So we're going to get 28.8 pi for this portion and 80 pi for this portion. And then over here we would have 16 pi. So then we're just going to add all those together to get our surface area for the cone and cylinder put together, and that would be 124.8 pi. We are working with inches here, and since it's surface area, it's going to be inches squared. So surface area for this figure is 124.8 pi inches squared. For this next example, you can see we have a half sphere because we would not include this base, plus the cylinder, which again, we're only including one base for. So here's our formulas, 2 pi r squared for this half sphere. We just took half of the sphere formula. And then for our cylinder, it's 2 pi r h plus only the one base, pi r squared. So this is what we get. So when we plug in our values here, we would have surface area equals 2 pi, and our radius is half of that, so it's 6 squared plus 2 pi, again our radius is 6, times 13 is our height right here, plus pi, our radius is 6 squared. So here we would get 72 pi plus 156 pi plus 36 pi. Since we have pi for all of our values, we're going to leave it in pi. So our overall surface area for this half sphere and cylinder would be 264 pi. And since we were working with inches and its surface area, inches squared.